I want to continue my discussion of duration by doing a numerical example. And in the last tutorial we said that duration was kind of an average of the time periods until you get your money. And we did some intuitive thing where we said it's kind of a balance point. If you looked at a diagram with all the cash flows in the different places and you wanted to stick a little balance point underneath it. Well, here's how you do the calculation. We said that duration was equal to a weighted average of these time periods, and the weight was equal to the present value of each cash flow divided by the price of the bond. And if you added up all of the present values, you get the price of the bond. So what are you getting? You're getting the percentage of the cash flow in present value terms that's received in time period T. And so let's look at some actual numbers. It might be a little bit clearer. And I've written this out to save a little bit of time. Say we have a bond with a 6% coupon, an 8% yield to maturity, 3 years until it matures, and a maturity value of 1,000. So if we know what the coupon rate is, we take the coupon rate and we multiply it by the maturity value and we get the coupon or the interest payment. So you're going to get $60 a year in interest, and then you're going to get back $1,000 when the bond matures in year 3. So the bond pricing equation looks like this. Price of the bond equals $60 divided by 1.08 plus $60 divided by 1.08 squared plus $60 divided by 1.08 cubed. Now we could solve this out by using our financial calculator, but we actually need each individual present value to do this calculation. So let's calculate each one of these cash flows, present value of the cash flows separately. So 60 divided by 1.08 is equal to $55.56. And if we take this cash flow and we divide it by 1.08 again, it'll be the same as 60 divided by 1.08 squared. So let's divide by 1.08, and we get 51.44. And then the last cash flow is going to be 1.08 raised to the third power. Now what I've computed is 1.08 to the third power, but what I need is 1 over 1.08 to the third power, so I'm going to hit the 1 over x key to flip it over. Then I'm going to multiply it by the 1060. So I get 841.46. And let's add all these numbers up. That'll give us the price of the bond. So plus 51.44 plus 55.56. So we get 948.46 as the price of our bond. And let's write that down. And we can check. We can use the function in the financial calculator to make sure we calculated this correctly. I'm going to use this time value of money function thing. N is 3, interest rate is 8, the payment, which is the coupon, is 60, and the face value or maturity value goes in as the future value, is 1,000. Compute present value, 948.46, so that's perfect. We did it correctly. Now let's calculate the duration. The duration is going to be equal to 55.56, the present value of the first cash flow, divided by the price of the bond, 948.46, times 1, okay, times the first year, plus the present value of the future cash flow in year 2, 51.44, divided by the total number, 948.46, 46 times 2 plus that last cash flow, present value of the cash flow, 841.46 divided by 948.46 times 3. So let's just do that. 55.56 divided by 948.46 equals 0.058. Let's say 0.058, and we'll just round off to 6, okay? Times 1, so that's just the same. Our second number is 51.44 divided by 948.46 times 2. So that's 108, 0.1085, and then our last number is 841.46 divided by 948.46 times 3. And so that's 2.6616, let's say. All right, let's just add those numbers up. Plus 0.1085 plus 0.0586, and so that's 2.8286. 2.8286. Okay, it's less than 3, and if we want to go to that intuitive explanation I gave before, if I were to draw this cash flow diagram, first cash flow, second cash flow, and the third cash flow. $60, and 1060, and these time periods are 3, 1, 2, and 3. If we were drawing that balance point, the balance point would be right here. And this balance point would be our duration, 2.8286. All right, so the last thing to ask ourselves, what do we do with this? Well, we're interested in the percentage change in the price of the bond. And that's going to be approximately equal to minus the duration times the change in the interest rate divided by 1 plus the interest rate. So let's plug into our number here. We have minus 2.8286 times, and let's say interest rates go up by 0.5%. Okay, so the interest rate goes up to 8.5%. So our change is going to be 0.005, that's 0.5%, divided by 1.08. So let's see what we get here. We get 0.005 divided by 1.08 times 2.8286, make that a negative. Okay, we would expect our bonds price to change by approximately 0.0131, okay, or minus 1.31%. You would expect the bonds price to go down by 1.31%. Let's actually check. That's an approximation. Let's see what we actually get here. Let's figure out what the bonds price would be at 8.5%, and then we'll figure out the percentage change. So I'm just going to use my cash flow worksheet. I don't want to work out everything separately. And the bond is 3 years. Now we have an 8.5% interest rate. The coupon is still 60. The maturity value is 1,000. And we compute the price of the bond. So at 8.5%, the price of the bond equals $936.15. So the actual percentage change in the bond's price is going to be 936.15 minus the original price of the bond. Let's just scroll up there and see what that was. I think it was 948.46. It was minus 948.46 divided by 948.46. So let's see what we get here. We already have this number in here. So I'm going to say subtract. I'm going to change the sign back to positive. Minus 948.46 divided by 948.46, and we get, whoops, did I make a mistake there? What did I do there? Let me just check here. That shouldn't be. Did I put in the right price, right interest rate? 8.5%. I compute price 936.15. So let me see what I have here. 936.15 minus 948.46 equals minus 948.46. I can't get this right here. Let's do this one last time. 936.15 minus 948.46 equals, divided by, I think I subtracted before, 948.46 equals, there we go. That looks good. Okay, you get to see me make my mistakes here. Minus 0.01298. So it went down by about 1.298%. And our approximation was minus 1.31%. So you can see we got a pretty good approximation there. Now if you pick interest rates that are too far apart, you won't get a very good approximation. If you pick interest rates that are 3% apart, it won't work very well because of the curvature of that relationship. But this is something that finance professionals actually use. If you're a bond portfolio manager, you know that when the interest rates go up, bond prices go down. So if you think interest rates are going to rise, you want to shorten the duration of your portfolio. If you think interest rates will fall, you want to lengthen the duration of your portfolio to take advantage of the price increase. They don't do it a lot, but they will tweak it a little bit, and this is actually a tool that's used by bond fund managers. And if you own a bond mutual fund, one of the things they will tell you in the prospectus is what the duration of the portfolio is. So this is a useful tool to use. It's a powerful tool, and it gets used in real world finance all the time.